All right, this is section number 2. It's called simplifying radicals. And you're going to be able to do this using products and quotients and going through the process. A radical expression is anything that contains a radical or a square root. And it is simplified if it follows these 3 characteristics. Excuse me. Okay. So we're going to work through some of these. The first thing is using multiplication. So what we see here is we see the square root of 160. But that's not going to have a real number, a real answer. It's going to be an irrational number. So what we want to do is we want to break it up into 2 numbers that multiply together to give us 160, where one of them is a perfect square. Okay, so that's the process that we're looking at. We're looking at what number multiplied by them, what number multiplied by each other gives us 160. And in this case, it's 16 times 10. Well, 16 is a perfect square. So we break it up into 2 separate parts, the square root of 16 and the square root of 10. And the square root of 16, of course, is 4. So we know that our answer is 4 square root 10. Now, I understand that some of you have a button on your Little Evil Demon box that does this. You do what you need, but remember, you show your work or you don't get credit on a quiz or a test. So that's the way it works. Okay, so try this one. Find out what 2 numbers, one of them being a perfect square, multiply together to give you 72. Break it into those 2 numbers, and then take the square root of the perfect square. Okay, now we also have it to where we have numbers and letters. So I would do the numbers and the letters separate. Okay, I don't know how I think the book does it together, but I'm going to work with the square root of 54 and then the square root of n to the power of 7. Okay, so 54 is 9 times 6, so that's the square root of 9 times the square root of 6. This is not a perfect square, so what I need to do is basically I need the exponent to be an even number. If it's an even number, I can take the square root of it. So I'm going to break this down into n to the power of 6 times the square root of n. Okay. So now I have the square root of 9, which is 3, the square root of n to the power of 6, which is n to the power of 3, and then these 2 parts go together, the square root of 6n. Okay. That's how it works. Okay. So do the numbers, do the letters, do them separate. That's how I would do it. Okay, this one throws the negative m out front, no worries. Just kind of see how that fits in there whenever you write your final answer. Try that one. Okay. Now, if we have 2 separate pieces, we can multiply them together. Okay, so what we can do here is we can take the 2 times 3 and get 6. Okay, I can take the 2 times 3 and get 6. And the 7t times the 14t squared. Okay, so I get 6 square root 98t cubed. Now I want to find 2 numbers that multiply together to give me 98, and 2 numbers that multiply together to give me t cubed. So I do 49t squared and 2t. I'm going to factor, or take the square root of this. That's going to give me 7t. Still have this 2t, the square root of 2t, and then I just have to multiply and finalize. 42t square root of t squared. Okay. So it's a slow process. Don't be in a hurry, or you'll make a mistake. Okay. Here's a few. Let's do this one. 3 times 1 is 3, and then I have 18 times 6. So 18 times 6 gives me the square root of 108. Okay. Now I need to figure out what number that is a perfect square goes into 108, and it just happens to be 36. 36 times 3. So that's 3 square root 36 times the square root of 3. So 36 is 6. So 3 times 6 times root 3. So I get 18 square root 3, right, is my solution to that question. Try those 2 on your own. Okay, this one says we have a rectangular door, and its height is 3 times, or wait, a rectangular door in a museum is 3 times as tall as it is wide. So it's wide, and it's 3 times as tall. 3 times as tall as it's wide. So wide, and then this would be 3 times W. And it says, what is the simplified expression for the maximum length of a painting that fits through the door? Okay? So basically, what we're doing is we're trying to find out this value. So it looks a lot like the Pythagorean theorem. So we're going to do we've got this, we know we're going to use the Pythagorean theorem. We've got d squared is equal to w squared plus 3w squared. Okay? We get w squared plus 9w squared, so we get 10w squared. We take the square root of both sides, pull out the w, we get the distance is equal to w times the square root of 10. Okay. So w times the square root of 10 is what we're looking for as our answer. Remember, always pause it, rewind, whatever you need to watch it. Now we've got the division stuff. Okay, so we're just going to break numbers up. Okay. So what we do in this case is we do the square root of 64 over the square root of 49. So that is going to be 8 over 7. Okay. Now for this one, you notice first that 8 and 50 have something in common. They have a 2. So what you can do is you can factor that out first. Okay. That's what I did, or that's what the book did. Sorry. Okay. And they divided not only by the 2, but also by an x. So that's where the x went. Okay. So then we have that over that, and that becomes 2x, where's it going? 2x over 5. Okay. So the square root of 4 is 2, the square root of x squared is x, the square root of 25 is 5. Okay. I would say try those 3. See what you find. All right, now one last thing. Rationalizing the denominator. Okay? And basically, one of the rules, if you remember, all the way back at the very beginning, is that you can have no radicals in the denominator of a fraction. Okay? So you can't have any radical in the fraction. So what we have to do is we have to get rid of it. Okay? We can't have that square root of 7. So what we're going to do is we're going to multiply by the square root of 7 over the square root of 7. Notice that that's equal to 1. Okay? And that makes this a perfect square. So what we get is the square root of 21 over the square root of 49, which is the square root of 21 over 7. Okay? So we're going to do the same thing here. We would multiply by the square root of 8n over the square root of 8n. Okay? So that's going to give us the square root of 56n over the square root of 64n squared. So the square root of 56n over 8n. Okay? Now, of course, if this could simplify any, we would go through the process of doing that, but I'll let you figure that out. Okay, a few more. In this case, remember, break it up. Square root of 7s over the square root of 3. Okay. And here is your check. All right. That's section 2, simplifying radicals. And hopefully, if you need to, go back, watch anything, ask questions. See ya.